Welcome to the Flat Earth Genius. I am the Flat Earth Genius, and we're fixing to go down into the rabbit hole. So join me as we talk about this wonderful subject of the leap year. Hello everyone, it's me back here. Notice I got my handy little board up here this time. Let me pull my chair up a little bit. Get a little more up close and personal. This video is an addendum to Antonio Subirats' video on the leap year, which I will switch over to and show you what I'm referring to. It's this video here, and as you can see, this is what it's called. If you go to Antonio's website, you really need to watch this video. It's long, almost 3 hours, but you don't have to watch the whole thing. You know, he kind of gets through most of the information in the first hour or so. Here's just a few seconds of what it is. Hopefully you'll be able to hear this and make sure my volume's up. Okay.
Oh, look, 2014, this is the year, 2014, 22nd of December, the shortest day. Then, the year 2015, 22nd of December, the shortest day. Between them, 365 days even, exactly. Then, from 2015 to 2016, 22nd of December, shortest day. 2016, this is 2016. 21st of December, shortest day. And that is understood because they added 29th February. They didn't actually add it, they named it 29th of February. But counting within their calendar, we understand it from the 22nd of December to 21st of December 2015 to 21st of December 2016. We are 365 days. So we know that 2016 is the leap year according to official information, but it is not.
So I encourage you to go watch the whole video. I know that probably made no sense just coming in the middle of it. But what's going on is that, and I've got this diagram here. Oops, I knocked something over. Okay, I've got this chart here that I made up on my dry erase board to show you this. Okay, what the claim is this right here is the globe understanding of leap year. They tell us that we have 365 and a quarter days every year. So after 4 years, you add up the 4 quarters, and that gives you a 1 to carry over, giving you 366 days on the 4th year. So as you know, our calendar, every 3 years, we have 365 days. And then on the 4th year, they add these 4 quarters up and give this 4th year the extra day and make it 366. So we add February 29th every 4th year. 2016 was the last, 2020 will be the next. An easy way to remember, leap year always is the same year of the presidential election. So this is the globe understanding. Well, Antonio's video with the other guy, I'm not sure what his name is, Sergey maybe. The point is there's a huge problem with this because this isn't what we observe and this cannot be explained. They have no accounting of this. You know, whenever you are an accountant, your numbers have to square away. So let's say I run a restaurant, and I put on the paperwork that there was $200 in the till and $50 in the safe, I should be able to go the next morning and find $200 in the till and $50 in the safe. That's proper accounting. So everything has to add up. So when the globe math people, the globies, tell us 365 and a quarter days per year, so they just kind of float the quarter for 3 years. They float 3 quarters, and then on the 4th year they go ahead and account for it and throw in that extra day. Okay, but is this what we observe in the real world? This is what we're going to look at. Here we got the sun, of course, and this is the earth. This line here represents noon. Imagine this board is a clock, per se. This is noon, high noon. This would be 6 p.m. down here, high noon. This is to show this is 12 o'clock p.m. And this is a virtual time. Time as in 12, 1, 2, those things, those are constructs. Time is a construct in the sense of our clock. That is something we created to go along with the observations. But we can alter times on our watch. You can get it and turn the wheel or change the button and change the time. So time isn't static. You can alter that. But solar noon is when the sun is at the highest place in the sky. That's called solar noon. So whenever the sun is at its maximum height above you, we know that's solar noon. So we set our virtual clocks to noon, 12 p.m. Whenever the sun's at the highest in the sky. That's the way we sync up our clocks. So anytime the sun is at the highest in the sky, we know that as noon. So every day, when you go outside at noon at 12 o'clock p.m., that will be the time when the sun is the highest in the sky every single day of the year. That's how our clocks are set. 24 exact hours, they've broken a day. One complete revolution of the Earth is broken down into virtual time called 24 hours. So we've divided those seconds and minutes and hours out into proper lengths so it all fits exactly from one solar noon to the next solar noon. That's how we calibrated our clocks. So 24 hours is calibrated off of one complete revolution of the Earth, so from solar noon to solar noon. Okay, so and solar noon is always 24 hours apart. Even though in the summer days are longer, in the winter days are shorter, solar noon is always exactly at 12 o'clock p.m. Okay? So if you look at these numbers, this is what our calendars follow. So if the year was 2013, we had 365, 2014, 365, 2015, 365, and in 2016, presidential election year, 366. Because they took the 4 quarters and added them to the final year. And it works out. That keeps our calendars in sync, you know, because for some reason, our year is either not exactly, 365 days, or something else is going on. And this is what Antonio pointed out in this video. Something else is going on. There's not 365 and a quarter days in a year. And I'm going to explain this to you right now. This is impossible. There could never be a decimal of a day in a year, because a year, in Antonio's video, they used the shortest day of the year, which is the solstice in the winter. like December 21st, December 22nd. It changes from year to year. But I'm going to use the summer solstice, which happens in June, like June 21st, June 22nd. Just, it works the same either way. They're reference points. We can reference this because whenever we physically calculate the length of day every day, one of these days is going to be the longest, and that's what we call the solstice, the longest day of the year or the shortest day of the year. Well, the summer solstice, the longest day of the year, is observable, and we know when it happens. So that very day, we consider that the solstice. So a year is considered, let's say you're racing on a NASCAR circuit, right? You have that's called the start and finish line. So as soon as you take off, you have started, you go all the way around the NASCAR track, and you come back to the start finish line. And then that represents one lap, right? So this is in the same way as the Earth makes its revolution around the sun. As it comes back to the solstice in the summer, that's considered 1 year. Now you can start this cycle anywhere you want on the solar year. You could start it here, but when it gets back to there, that's a solar year. If you start here, when you get back to there, that's a solar year. But this is a hard measurement because it's the longest day of the year. So it's a verifiable number. The day before it's shorter, and the day after it's shorter. So it's a peak. So we have a defined day. Or the shortest day of the year like Antonio did, so we have a defined day down here. But I'm just choosing this one. So when the Earth makes one complete circuit, so we're going to go back to 2013. On 2013, when the Earth took off from the start line, made its lap around and came back to the finish line and had one solar year, we had 365 days. The Earth revolved 365 times in this revolution. We had 365 sun PM, 12 PMs to 12 PMs, because it starts at 12 PM and ends at 12 PM, and every day at 12 PM is another day. So as soon as they said go, we start counting. Okay, 1 day, 2 days, 3 days, 4 days, 5 days, keep going, blah, 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 blah. 365 days, 12 noon AM, stop the clock. 1 year, 365 days. This is what we observe in the real world. This is why there can never be a decimal in a year, because a year is from noon to noon. That's a single, that's a unit. There is no fraction in this. We're not taking the Earth's orbit from there to here, you know, starting here and going just to here. Now that would be a fraction of a year. Or going over here, that would be like 365 and a quarter, right? A quarter of a day is 6 hours. So what they're saying is we went from 12 noon on 2017 to 12 noon on 2018 and came back to the start finish line. But according to the globe measurement, there's 6 hours more to account for, because they say it's a quarter day. Well, that means there's 6 hours that we have to add in to this rotation. So instead of 12 o'clock p.m., we're now at 6 p.m. But we know that doesn't happen because our clocks stay at 12 noon every time the sun is at the highest in the sky. If this is the case, every day our clocks would slowly get off of 12 noon. When the sun is at the highest in the sky, tomorrow it's going to be a few more minutes past noon. And the next day, in a couple weeks, it'll be 1 o'clock in the afternoon when the sun's in the highest. And after a full year, because there's a quarter extra day, by 1 year, our clock is going to say 6 p.m. when the sun is at the highest point in the sky. But we know that doesn't happen. And then the next year, as the Earth makes its revolution. You got to add 6 more hours. So now instead of 12 p.m., it's 12 midnight when the sun is at the highest in the sky. And then this year, it's 6 a.m. when the sun is at the highest in the sky. And then finally on this year, we're back to noon because you've added 6 hours and you've made it all the way around back to noon. So they say instead of doing that, we just add it all up at the end and just do it in one full day. But you can't do that. You can't, there is no filing cabinet for quarter days anywhere. They have to be accounted for as it happens. You see, if there's an extra quarter day, then it has to be figured in. And it's not. There is no extra quarter day in a calendar year because a calendar year is from any one point on that year to that same point again that following year, where the sun is at the same exact place in the sky, which is solar noon or whatever. If you want to do it from 2:15 in the morning, then it's 2:15 in the morning, but it's hard to determine, you know, exactly where that point in time is in the day because the sun is our indicator. So 12 noon is the, you know, solar noon is the best way to do it. So, but here in the real world is what we observe. Exactly what our calendar is doing. So they've set our calendar to exactly what actually happens in the real world, but then they explained it away with this globe math, which is completely bullshit. This is fictitious. This never happens. This is exactly what happens. And if this is what happens, you have to understand. If this right here is what happens, the globe is dead because the globe can't answer this. But here's what we actually see happen. So let's just say this is 2013, 14, 15, and then the leap year of 16. In 2013, there was 365 days. 2014, there was 365 days. Now these are observable days. Sunrise, noon to noon, that's a day. 2015, 365 days. Now, on the fourth year, every fourth year, instead of 365 days in a solar year, there's an extra day thrown in all by itself. There's 366 days, which shows that our cosmos is not in a static, perfectly timed time. You know, here's the camera. We're not doing like the clock on the wall. Our years don't go exactly the same every year. We have 3 years with 365 days, but then on the fourth year, the year slows down just a touch, enough to give us one exact more day. And then the next year, we're back to 365 days. Well, that can't happen in the heliocentric model. There is no mechanism to every fourth year for the Earth to all of a sudden slow down in its course around the sun and then start speeding back up again on the next 3 years and then slow down again. But it's exactly what happens. So the only way they could explain that away and deceive people is to use this formula right here, which is what we were always taught. But yet our calendars have always told us the truth. Our calendar has always told us exactly what happens. But the math liars and the globe liars and the deceivers have taught us something completely different. And in Antonio's video, if you look underneath in the comments, all you see is globetards trying to say, but we just hold them. It's like holding the quarter. These are quarters and these are dollars. I have $365.25. Well, I'm going to give you 365 and I'm going to hold a quarter back and put it in my pocket. And then next time I'm going to give you, and next time. So on the fourth time, I'm going to go ahead and pull out those other 3 quarters and add them to the 365. And of course, I got to go ahead and give you 366 on that fourth time. But the thing is I accounted for the quarters because they were in my pocket. There was physical quarters, money, representations of money in my physical pocket, so there's an accounting of them. I can explain where they went. Explain where this quarter of a day goes when these globe earthers are supposedly just stashing them away till the 4th year. What are they doing with these quarter of a days? They can't answer that. There is, because they're not going anywhere. If they were stashing it away, our clock would be changing every year. Our clock would, in fact, it would change on a daily basis. We would have to reset it, because every day would be just a few minutes longer than 24 hours. But that's not what happens, because if they did that, then what would happen is on that 4th year, all of a sudden our clocks would be off majorly, because now all of a sudden the Earth slows down and gives us a whole extra day in its actual physical, not anything on paper, but what really happens in the real world is on the 4th year, every 4th year, and that's what Sergei was showing on the charts he did. Watch that video, and they went through and they checked it for many years, and it recurs every time without a doubt. On that 4th year, for some reason, the Earth gives us a whole extra rotation in that year. And that shows, first of all, that it's a very well-oiled, very intricate machine, our system, our cosmos, and it's not static. It changes. 3 years of this much, and then 1 year of a different amount, and then back to 3 years of this much, and then a year of a different amount. That's not static. That's a variable. And that can't happen in the heliocentric model. They can't, gravity is the only force, and gravity doesn't have a brain to think, well, okay, it's the 4th year now, so it's time to go ahead and slow down a little bit and give them an extra day. Gravity can't do that. All it knows is, if it existed, all it knows is it's a slave to physics. It's a slave to physics. And it's going to do the same thing every time. And if it changed, then it would throw the whole system out of balance, and the universe would cease to exist, because the entire universe would be thrown out of balance. It's like if you have a bunch of gears spinning, and one of them loses some teeth or breaks, all the gears fly apart because they all rely on each other. And so we just cannot account for these quarter days that the heliocentric model tries to pass off on us. So I think I've explained this about as good as I can. I don't want to get too long in this video. So the breakdown of this is, the globe model teaches us that every year has 365 and a quarter days, but yet our calendars in real life, we have 3 years of 365 days, and then on the 4th year, we have what we call leap year, February 29th, where we go ahead and throw in an extra calendar day to compensate for these 4 quarters that were stored up. But the real observable world, this is impossible, because you can't have a decimal point of a day, because a day is from 12 noon to 12 noon, from high in the sky to high in the sky. That's a hole. If I said, here's the top of a pie, and I went like this, this is the top of the pie, and I went all the way around and came back to the same point, that's one whole revolution, not 1.25. So if this is high noon, and I go back to high noon, that's one complete day. Now if I went 6 hours beyond that, now that's a quarter of a day, but I'm already into the next actual solar day, so I can't count this as anything. This is already into the next day. This is a day. So this doesn't exist. It can't exist in the real world. There's no way to account for these 4 quarters. And in fact, what we actually see is literally this is what happens in the real observable world. 3 years of 365 days and a 4th year of 366 days. This is complete rubbish. This heliocentric model is defeated by this one fact right here. Completely destroys the heliocentric model. There can be no other explanation. Let the heliocentrists rebuke this video, or Sly or Woofy or whoever else wants to. Let them get on here and make another video showing me how I'm wrong here. And watch what they're going to do. They're going to come back to these quarter days, and they're going to try to put these quarter days in their pocket, but yet they have no pocket. There's nowhere to put these quarter days because there are no quarters. From solar noon to solar noon is 1. Do you see another quarter in there somewhere? It can't be, because this is defined by the fact 1 is defined as a unit. 1 complete unit is 1. That's not a quarter, that's 1. It's by definition 1. So every time that sun goes from 12 noon to 12 noon, that's 1 complete day. There's no extra day in there because noon is noon. And our clocks are adjusted to that. So I hope this video helps. I'm going to put out some more videos, some other shorter videos, maybe 20, 30 minutes. I've got some more things to put out on Chris Curtis, I believe his name is. He's a flat earther, but he's been doing stuff on there should be only 12 hours of daylight on a globe. It's impossible to have more than 12 hours of daylight on a globe. And he's genuine, but he's wrong, and I've got my globe over there, and I'm gonna do a video showing him how he's wrong. That on the globe model there can be more than 12 hours. It's just the way it is. The globe model works in that area, so we can't use that as a proof of flat Earth. So I'm going to do a video on that. So anyhow, I appreciate y'all. Let me know what you think. If you got any rebuts, make a video. Prove me wrong on this. Prove Antonio and Sergio wrong, but I believe this is the deal. I hope I helped clarify some of it. So y'all take care. God bless. This is the Flat Earth Genius, and I'm out.